video viewers. This is Mathematics with Dr. OJ. In this video, we shall talk about differentiation of implicit functions. Kindly subscribe to my video channel by clicking the subscribe button below the video. It is free. And the notification bell, so that each time I upload a video, you'll be duly notified. Thank you. Implicit functions are functions that have peculiar nature. They are unlike explicit functions, which we have so far studied. In explicit function, y is a dependent variable, but in implicit function, y is an independent variable. Before we go on, let's take note of the following important points in implicit functions. Note, in an implicit function, y, like I said, is no longer a dependent variable, and anytime a variable y is differentiated, the differential coefficient dy dx must be written. Let's look at example 1. Find the y dx if x squared plus y squared plus sin y is equal to 3. Now, we differentiate the given expression across board to obtain 2x plus 2y the y dx. Like I told you, anytime you differentiate y, you must include the y dx. So, when you differentiate x squared, you have 2x. Differentiate y squared, you have what? Plus 2y the y dx. Now, when you differentiate sin y, anytime we differentiate sin x, we have cos x. So, this time around, you are differentiating sin y. So, you have cos y, then the y dx. So, when you differentiate the constant, you have 0. So, you have 2x plus 2y the y dx plus cos y the y dx equals to 0. Now, you collect like terms. So, by collecting like terms, you have 2y the y dx plus cos y the y dx is equals to minus 2x. Now, that implies, since the y dx is common here, we can factor out the y dx to have the y dx into 2y plus cos y, which equals to what? Minus 2x. Now, we divide both sides by 2y plus cos y. So, we have the y dx will be minus 2x all over 2y plus cos y. So that is the solution to the first problem. Let's look at example 2. Find the y dx and the square y all over the x squared if 3xy plus x squared plus y squared is equals to 5. We are asked two questions for one example here. Because in example 2, we have to solve the problem. There are two ways. The first one is to find the y dx, and the second one is to find the square y all over the x squared. So, solution. Differentiating from left hand side to right hand side, that is, differentiate across board. So, when you differentiate 3xy is a product function. So, you can, fix y, differentiate 3x, or you fix x, differentiate 3y. So, differentiating 3x now multiplied by y, we have 3y, and plus differentiate 3y multiplied by x, you have 3x the y dx. Then whenever you differentiate x squared, you have plus 2x. When you differentiate y squared, you have 2y the y dx is equals to the constant 0. So you now collect like terms here. What are like terms? You look for those that have the y dx. So you bring them together, and those that don't have the y dx, you take them to the other side. So you factor out the y dx here, so we left it with 3x plus 2y, then is equals to minus 3y minus 2x. Now, by dividing both sides by 3x plus 2y, this is the value you are going to use to divide both sides, so as to have your dy dx. So we have the y dx will be minus 3y minus 2x all over 3x plus 2y. So that solves the first problem in this in example 2. Now, to find the square y over the x squared, we recall that the square y over the x squared is equals to d dx of the y dx, which is d dx of what we have obtained as our dy dx in the earlier solution. So that will d dx of minus 3y minus 2x all over 3x plus 2y. Now, to differentiate that, we use quotient rule, because the function is now rational. So our u will be the numerator which is minus 3y minus 2x, and our v will be the denominator, which is v is equals to 3x plus 2y. So you now differentiate u with respect to x, and also differentiate v with respect to x. But don't forget, because this is an implicit function, anytime you differentiate y, you must include the y dx. So the u dx now will be minus 3 dy dx, because you are differentiating minus 3y. Then minus 2x will be what? Minus 2. So the v dx will be what? 3 plus. When you are differentiating 2y, you have 2 dy dx. Now, this is the quotient rule. The square y over the x square will now be what? In our quotient rule, if you recollect very well, we have d du dx minus u du dx all over v squared. So, just substitute for this value we obtain into v du dx minus u du dx all over v squared. So, by the time you do that, now you expand this. Okay? So, we have what? 3x times minus 3 dy dx, you have minus 9x dy dx. Now you have 3x multiplied by minus 2, you have minus 6x. Then plus 2y multiplied by minus 3 dy dx, you have minus 6y dy dx. Plus 2y multiplied by minus 2, you have minus 4y. Then minus 3y multiplied by 3, you have minus 9y. Then minus 3y multiplied by 2 dy dx, you have minus 6y dy dx. The minus 2x times 3, you have minus 6x. The minus 2x times 2 dy dx, you have minus 4x dy dx, all over 3x plus 2y all squared. So by the time you add this, you now what? Collect like terms. But before that, you expand the one in bracket here. So you have minus times minus 9y, you have what? Plus 9y. Then minus times minus 6y dy dx, you have what? Plus 6y dy dx. Then you have minus times minus 6x, you have plus 6x, and minus times minus 4x dy dx, you have plus 4x dy dx. So that is the expansion of this. All these remain the same because we're not expanding anything here. So all over 3x plus 2y all squared. So by the time you now collect like terms, you observe that minus 9x dy dx plus 4x dy dx, that will give you minus 5x dy dx. Then minus 6y dy dx plus 6y dy dx will cancel out. That's 0. Then minus 6x plus 6x, that's 0 also. So we are left with what? Minus 4y plus 9y, and that will give you plus 5y. Everything all over 3x plus 2y all squared. So the square y, the x squared, will now be minus 5x into, your dy dx is minus 3y minus 2x all over 3x plus 2y. We have substituted for that value there. So plus 5y all over 3x plus 2y all squared. So by algebraic expansion, we have, just find the LCM here. You expand this. You have minus 5x into minus 3y minus 2x plus, by the time this one becomes LCM, this one 5y over 1, LCM is 3x plus 2y. 3x plus 2y times 5y, you have 5y into 3x plus 2y, all over. So, this is LCM here, is the denominator. By the time you divide it by this, the 3x plus 2y all squared becomes 3x plus 2y whole cube. So now expand. So minus 5x multiplied by minus 3y will be plus 15xy. Then minus 5x times minus 2x will be plus 10x squared. Then plus 5y times 3x, that's plus 15xy, plus 5y times plus 2y, that's plus 10y squared. So all over 3x plus 2y all cube. Hence, your d square y to x squared will be, now collect like terms and add 10x squared plus 10y squared. Then you have 15xy plus 15xy, that gives what? Plus 30xy. All over 3x plus 2y cube. So that is the result for d square y all over dx squared. So you observe that we have come to the end of the solution to the problem. So don't forget to subscribe to my video channel by clicking the subscribe button below the video. Thank you and God bless you.